Hey,
Hello.
hi. Sorry, I think that was confusing. I posted
Oh, I
this
should
email
have
and Nick
checked.
confirmed. Yeah, Nick told me he was not available just at 7:30 a.m. So
Yeah.
that. So I'm writing the answer for this, but I'm just copying it word by word. I haven't read it, because I thought it was so complex understanding.
Is this one the sum in the other?
Yeah. The sum when it's ordered correctly.
Oh, let me see.
So one thing they're doing is this thing they call padding. It's actually in page.
So they want the lists to be the same length then.
Yeah, 215.
Okay.
So actually, I'm just copying.
I want to read the
Everything.
description. Yeah, go ahead.
Yeah.
Oh, they did the first one recursively.
Yeah.
Why not?
I think at some point they've created this list. Oh, this is it. No, but that's not this. So they keep using this linked list node that I don't know where they get from.
It's probably defined once and used for an example. Like, look at the first one. Maybe it's there. Otherwise, it's in the examples during the description. Let me linked list node, right?
Yeah.
That would be our node, probably. This is chapter 2. It's called node in the examples, but see if it makes sense. Page 92.
Okay.
I'll go back and check the exercise. You're actually right. It refers to linked list node and doesn't give you the class. I assume it's a mistake on the book. It's actually node. Let's see what it does on that one. Well, next data. Yeah, it's node. It's a bit complicated, but not so much. It's doing it recursively, starting from the higher digits, and then it's going to add the carry as when the recursion is being closed. So they will be added at the end when it's going back. I don't know if this makes sense.
I don't think so.
So when you do recursion, you're going to have something that you're going to start from a point, and then you're going to repeat that point on a series of time.
Yeah.
Pretty much. It's just like an iteration. The only difference is you do one call inside the other. But then you start the calls. What you see is you call the first time the function, then it's going to recur. So it's going to call itself again, then again, then again, then again, then again. And it's going to do the first part of the code of each one until they call the next one. But then the last one ends at some point, which means the first call, the last call you did is going to end, and it's going to go back to the one before.
Yeah.
That's when you start closing the recursion. You're coming back pretty much, right?
Yeah.
And so depending on where you add the carry, you end up doing it while you are. If you do it when you're going back, after you've done all the recursive calls, you are pretty much adding the carry in the opposite direction, which means you do it correctly, like you started from the last one. Even better, you can imagine a series of there is some code that is when the recursion starts, you get some code, then you call another recursion. So you start that code again, then you get another recursion, and so on. So you have the first part of the code, because before you recurse, is going to be called in the direction you are going, because every call is going to stop and then call the next recursion. And all the code that is before that is going to be executed. All the code that's after is going to be called later. When you get to the last one, you do the first part of the code, then the recursion doesn't work because it's the last one. So you do the second part of the code, and then you go back and you do the second part of the code of the second to last one, and so on. So you can imagine a series of the first part of the code that goes executed, first, second, third, fourth. Then the last part of the code is executed in the opposite direction, fourth, third, second, first, and then you're done. But I don't know if this was clearer. Let me show you. Let me use the do we have a whiteboard? No. Can I create one?
We are not using Zoom.
No, but I can find one online.
Oh yeah, makes sense. But I think it makes sense what you're saying. Like it's more of adding the going and adding adding the values to sum to a stack, and then adding them back when you are recursing.
You are adding the carry back because you get the carry from the previous one. Well, look at the code. It's actually look at line 39.
Line 39. Okay, that's probably in the next page, right?
That would be page 216.
Yeah, line 39.
Okay, see how okay, now, sorry, 36. That's the demarcation line. That's when the recursion continues, right? So 36.
Yeah.
Because that's where, so the part before is going to be called in the direction. Do you have an example? Let's say you are adding 999,111. Okay, so 9 plus 1. So it's going to do. Actually nothing. That's the closing. The first one, the first like 31 to 34 is the closure of the recursion, right? One possible recursion. You're out of nodes.
Do they call it the base case or something? The something case.
The guard.
Guard something.
I think I know the name in Italian. I'm not sure in English. Give me a second. Exit condition. Exit condition. That's not how we call that. We used to call them at school, though. I wonder. Yeah, that's the bad thing about studying in the wrong language. Anyway, yeah, let's call it exit condition if you want. There are actually two, of course. One is we are at the end of the node. The last one is actually we are done. No. No, sorry, I'm totally wrong because it's going to recurse otherwise. Yes, it stops when we are at the end of the lists.
Yeah. So that's what they're saying here, that if it's null, if list 1 is null and list 2 is null, you return the sum.
You return I think you return an empty result. It's like let's say we are summing 0 at the end. I think. Let me see.
Yeah,
you return an empty partial sum. And partial sum is sum is null and carry is 0.
This partial sum thing. So the partial sum, they've just declared it as
like it's line 1.
Yeah, it's just a class that has two functions. One is the node. Node sum is null.
Oh, it's two attributes.
Okay.
Those are attributes, public attributes. Or I don't know, I don't remember how they call them in Java. I think it's the same thing.
Yeah.
It's not a function. It's like, remember we used the struct object. It's the same thing.
Yeah. But why are they creating a node called sum? So.
Oh, why is that a node? Good question, actually.
Yeah, because I thought the sum will just be an integer.
Oh, no. That's the resulting list. It's the list. It's the list that represents the sum of the two. That's the result.
Silly Mike.
Oh no, don't worry. I got confused for a second there too, and it's fine. So the idea is you do all the sums before, and you actually, this is really strange. When do you build back? Oh yeah, of course.
When you're unpacking.
Now that's really strange, right? Because it's going ahead to get the carries, and then it's going to build the result when it's coming back.
But the first carry is 0 because when you get that the nodes are none, the carry becomes 0.
Yes.
So they're not going to get the carry. They're just going so that they come back when adding.
No, wait. The first carry you get is going to be 0. Yes, but that's for a sum of 2 null digits. So that's a sum you're not going to do. The point is the first real sum is going to have carry 0, which is correct because this is the first one. I really would wish I had a whiteboard. That it's actually not that complicated. I think I'm explaining really badly. If you draw this one, I think it's going to be way clearer. Sorry.
Yeah.
Can I?
Yep, you can share.
Let me see if I can find it first. Really? I need to log in now. No, I'm going to look for another one. Oh, you know what? We should really make one. Okay, this one looks good. Okay, let me share my screen. This one.
What are those?
Let's make this easier. It doesn't look like a 9, does it? Where's the?
I think if you say it's a 9, I understand.
How much?
301. 300, I think.
Yeah, I assume that they are going to ask this. Actually, I would to see if I get you. Oh God, how did I remove you? No. Oh, back. Perfect. So this is the idea, right? So what if I? So let's see. How do I? The idea is you have the code in each method is divided by the recursion call, right? This is the before and the after. So what happens is you get, let's call this the first part and the second part. You get the first part, which is going to check, which is going to be called with 1. Then there is the second one that's going to be called with 9. I'm sorry.
Yeah,
9,
no
9.
worries.
Then there is the third one that's going to be called with, and this is fucking.
Did you mean 90?
I did. Oh my God, but a little bit more like.
Yeah, I think you.
So I'm going to put the 0 there then. Yeah, so 90, and then it's going to be 91. And then it's going to be, and this is the trick. Can I move it? Can I like delete this one? Now, can I move? Oh, yeah, I'm going to do. Oh, help. How do I move here? Well, I like it so far. But I would like to move everything left. Oh, no, this is not going to work.
But you can just put the arrow to point leftwise.
Yeah, but I'm going to do, yeah, okay, let's do it like this. I just, OCD, sorry about that. And this is the important one, right? This is how it's going to be called.
Yeah.
Then you get the second part. The second part is going to be sum and carry, right?
Yeah.
And then start closing back. So, and this, I wanted these to be on the same level. But the idea is, so this is A, this is B, this is C. So this is
A prime.
C.
Okay.
It's
That's C
going
prime.
back. Oh yeah, let me do it like this time. Right. So maybe it's clearer. From here, of course, because this is return. So it's going to do C1. And how is it going to do it? It's going to do the sum now. So it's going to do with the curries. It's going to do 9 plus 1 plus 0.
Plus 0.
That's why it's 0, right?
Yeah.
And then it's going to put this one inside.
Of that.
Somehow it's going to be careful not to add if both nodes are null.
Mm.
If is doing instead before some sum, it's going to put, oh yeah, of course, and that's going to be rest of the division by 10. That's going to be the going into sum, and instead before does. Yeah, it's just the first time it's going to return just the node. If the result is null, like it's going to be in that step, then it's just going to return the node. Otherwise, it's added. It's an interesting solution in 3 lines of the problem we had. That every time we needed to check if when you want to add the node, first you check if the list is actually empty or not.
Mm.
Okay, so look at. Let me show you. It's this one. When it needs to create the node to add to the, I mean, this is actually altering the list, the result list, so that it contains the node of that we are calculating now, right? You give it a list, and I guess you put it here. You put if this is a 10, you put the 0, because this is the digit, not the carry. So it's going to check if it's going to create a node to put the data. It's going to check that the list is not null. If it's not null, then it's going to do this, which is a classic way. Otherwise, it's just going to return the node, because that's the first one. And note that it's building the result from the back up.
Mm-hmm.
Right? Because we are getting the last digit first. Okay.
Yeah.
So this is the idea, right? So this is going to be this is actually going to be a node with 0. This is going to be sum. Sum is going to be a node with 0, and carry is going to be 1. And yes, I'm awful as writing, right?
Mm-hmm.
Then it goes here. It closes B. And this is going to be 9 plus 0 plus 1. Sum is going to be it goes backwards, right? So it's going to be 0 again, because there's the carry, and then 0. Oh no, sorry. I'm making, oh god, a child would do better. Right? because this is going to be 9 plus 1, 9 plus 0 plus 1. And then finally, it's going to be, you know, the rest, right? But this is the idea. This is really interesting. It has been a while since I've done recursion the last time, but yeah, this is the trick. Something happens before, something happens after you go on recursing.
Yeah.
So does this make it a little bit clearer for you?
Yeah, it's clear.
And the rest is the same, of course.
Yeah. Maybe we can just implement it without looking at the solution now. Now that we understand.
At this point, yeah, after cheating, why not? Go. Can you share your screen though? I want to hear you say it.
Yeah, so I was doing it in Python because I found myself here alone.
Ah, okay, but did you click the wrong button?
Yeah, I clicked the wrong button.
Yeah, okay, that's it. I just wanted to hear you say. I mean, it was too clean. For a moment there, I was afraid you had lost connection, but it was too clean.
Yeah, so I created this class, linked list utils, and probably I'm going to do that like at before here.
Yeah, but remove the book then. If you're doing this without looking.
Why did I say that? Okay. I really want to cheat. I really want to cheat.
I have you on record. If you really wanted to cheat, you wouldn't be recording the session.
Yeah.
Although, if it makes you happy, we cheated more than enough.
Yeah, so let's just start. Like, I don't know if we wanted to do this or we just want to try fumble around.
I don't see the point. We looked at the solution. Just go. I would go straight.
Okay.
Straight on. But yeah, you're cool.
Okay, so maybe I need a node class, and I need to share my screen.
Oh no, don't worry. Don't worry. Besides, I really don't know Python much, so I'd rather just watch.
So self next value, and then next node self dot.
Wait, that's how you do the constructor?
Yeah.
Pretty ugly, isn't it?
It looks like the initialize for me. Okay, the only difference is like Python, whenever you see a danda, double underscore, you automatically know that this is like a function that you should not be calling.
Yeah, but still ugly.
Yeah. So it's double underscore is meant for private functions, and double underscore on either side is meant for
I see.
What's more than private? Yeah, something that's more than private. Something that's so sacred. Yeah.
Internal.
And then Now we want like to class node details, and
Do you have to declare getters for this or readers of some kind to get the value and the next node?
no,
Okay.
you can just get them, or maybe you can just do, if you want to them to be like getters and setters, you do like property and do def get var.
But you don't need to.
Yeah, you don't need to.
Okay.
And you say return self.var. Yeah.
You're missing.
Yeah, so that's how you do it, but
No need.
don't need to. So that's node details. I think this is what I want to use to add
Well,
I remember we did tests for this in the other.
Well, yeah, but because the original idea was we create a different method for the both directions, right? But if you're doing just one in this one, I would just do add lists, or even just add, to be honest.
So def add L1, L2. And I think the first thing they were doing was to get the length.
Don't go by memory. Do you remember what they were doing in general?
Yeah, so first you want to pad.
Mm-hmm.
Okay, because the first thing is like you have lists that could be of various sizes, and then you want to add zeros at the end of that list.
Okay. Padding is okay at the beginning, though.
Yeah, at the beginning, so that
And
you don't.
And then they were recursing. They were actually visiting the lists recursively, and then doing the addition on the when the recursion was closing. That's how I would describe it.
Yeah.
Right. Because it's more like they were visiting the list and then doing the sum on their way back.
Yes.
So start by padding then.
So here we want to like get LY length 1 maybe equals len
you can use this. It is suggesting you correctly. Actually, you should use them.
Actually, this is an AI thing.
Yeah, I know. And since it's doing its job, I would use it.
Yeah.
It should be able to guess length. Yeah, there it is. The second one. Oh, come on! You stole it. Go, well done.
Yeah.
I actually like his solution better than yours. Can you call it len L1? Oh, why L, by the way? L as
list
in
1 and list 2.
Oh, right.
And then I think here I need to have self. That's why he's crying. So def length and not, then if not It's none.
Ooh, none. I like it.
Return 0. Then here we have like length equals 0. I'm just trying to write.
Do it. Okay, I can. Can I suggest you do it recursively?
So that I find the length recursively.
How about line 15, something like return length self node next?
Return?
Return
Yeah.
length. The only thing is the head of the list. You need to remember which one is the. You want my help, okay?
Yeah. Sometimes when you say it, I can't just understand,
Okay.
and it's easier for you to show me.
I should have kept my mouth shut.
At least you didn't. So what did you want to say? +1.
Let's see. Yeah, this should work. The only problem about this one is that you lose the head, right?
But we're just getting the length.
Yeah, but I'm visiting, which means I'm moving the pointers. I'm moving node. Oh, yes. No, yes. You are absolutely right. Sorry, you are absolutely right. So this should work. Does it look like it would work?
I think this will fail. Yeah, it won't. Yeah, it will work. I think this will work. Do you need some unit tests?
No
need.
I in this particular situation, I wouldn't.
Okay.
Because we have the idea. I mean, we saw the solution. What's the point?
Yeah. So I think another thing that we lose here, if you do recursion, the space complexity will actually be O of n.
Well, because you have to come back.
Yeah, you have to use a stack to put all your stuff, then come back. Versus when you use iteration, you will only be tracking a value. So the space complexity is.
And it's still being ODN computation anyway, because you still need to go through the.
Recursion is not O of n.
It is in this case.
Yeah.
I think you're still going through the node one at a time, and you do all of them.
But you go and come back.
So it's worse, you say?
Yeah, it's worse.
Okay, so I like the simplicity of this, but maybe you're right.
Yeah, I think I think it's just recursion time complexity.
So it's usually recursion is associated with log dn. I don't know if this is general thing. It's probably not. So what you would do is something like I don't know if you can do this.
So 1 plus Tn minus 1.
Then we do something like this.
So the log of n complexity comes when you're doing
Trees.
binary search or something. Yeah, trees.
Yeah. Can you do this?
You want to share your screen? Or you're showing me something?
I'm
Oh,
writing in the file, so maybe something like this.
Yeah.
So plus equal works in Python.
Yeah, that works. And then now here, what we need to do is check if len L1.
There is a mistake, a very bad one. Okay, mind if I?
Yeah.
Yeah. And this is actually kind of bad. Now I actually lost. I actually lost the ad this time.
Yeah.
So maybe. Oh. How about this one? Oh, is this a?
Sorry, you're breaking.
Okay, sorry. Is list a reserved word?
Yeah, list is a reserved word.
How about L then? We are using L everywhere, so.
Yeah.
Why is he whining?
Yeah.
Why is there a mistake here?
Because of this.
Oh, fair enough.
Yeah, so if I do pass, I think that will go. But
Now,
now,
one thing I would say is maybe length should be private.
I don't know how to do private functions in Python.
Okay, you go ahead. I'll look.
Yeah, I think maybe the best thing I will do first is to make it with a danda, then underscore, and
Oh, it's the double underscore.
yeah.
And then you call it with the double underscore?
I don't know why today you keep breaking.
I really hope it's not me, but it might be me.
I know it's me.
I was saying, how do you call it?
Just do self.self, self.length.
Okay. Okay.
Yeah.
But the point of this is, unless you are using a method elsewhere, it's a good idea to have it private. And unless the method is very complicated, you don't need to test it.
Yeah.
Double advantage.
Yeah. That's correct. Yeah.
You can test it if you want. This is important. Nobody says you shouldn't test it. Or I mean, it's not like someone is going to hunt you down if you do. It's just usually you don't need to.
So if length of 1 is greater than length of 2, you want to pad L2, and then len L1 minus
can you use list when we are working on the list so we don't get confused? Do you mind?
Can we use list? Where do you mean?
In the names.
Oh yeah.
It's a bit.
List.
Yes, look at this.
Yeah,
remember
you
when
use those things, adding and finding the first one, then increasing.
It's Control A, Control X.
Control A, Control X.
Control A is +1, Control X is -1, and in the middle you move so you don't continue with the same number.
Yeah, I did something awful.
No, you didn't.
Yeah.
This is wrong, of course.
So
how do you do? Sorry, how do you do else if?
Elif. Yeah.
We don't need to pad in one case, right?
Yeah.
No, I don't actually. I'd rather do it like this. I think. Yeah, sorry, go ahead.
Self lists. Then
Length.
Difference.
Well, this is your padding. So referring to padding, you are padding the list according to a certain length. It's not like the method doesn't know that you were making differences, right? It just knows that you need to add 3 zeros.
Yep. So while lists while length is.
Can you do 4 in Python?
Yeah.
Why not 4 then?
For I in range.
Oh, I see why you don't do it. It's almost more complicated than writing in while.
Length. So that will start from 0, and what we want to do is self add before we want to add before lists node zero, and I think
very well. That's going to be done length times, right?
Yeah.
Okay.
Add before
self,
yes, self.
list.
Now it's
No,
a
node is actually, yeah, but you're going to call node the other one as well.
Yeah. So here node to, but next
Can
equals.
Can I ask for names that are a little bit clearer? How about how about node and new node?
Yeah. So,
Apologies.
New node dot next node.
You had to call it next node.
Yeah, because next is a
Oh,
word.
yeah, I like -1 points for Python then.
Yeah. So new node dot next node equals node.
That's pretty much it, isn't it?
We need to return it, I think.
Why?
How will we get the head?
Good question. Oh, this is actually tricky. No, because you are right, and this is actually add at the end of the list, though, because we are not adding before any node. This works if we are adding before the first node, because we are returning the new list, the new first node, right?
Yeah, we are returning the new first node.
Which means this can be a bit ambiguous, because what if I give you the second node of the list, because I think it's going to work anyway? But yeah, I was just thinking maybe.
So
because
yeah, okay, then I think that way we need to make the. You remember? I think we did this in one of the questions. Remember that question where we spent a lot of time and this is what we should have done? I don't know if you remember.
Yes. Same thing. We were building the result from the back up.
Yeah, we were asked that we have a node. I think it was, let me just find it because I can't go without finding it. Sorry. I think it will just be here. This before palindrome. Before this sum list. Write code partition. Was it this one?
Oh, I'm sorry. I'm looking at the wrong window. Let me say.
Write code to partition a linked list around value x such that all nodes less than x come before.
Did he? Oh, you created two lists here, right? And then you merged them. Oh no, this is even better. Yeah, look, line 23 at the bottom of the page.
Yeah.
This was even better. You added it at the head or at the beginning or at the end, depending on where it was.
Mm-hmm.
Right. Look if you like it more now.
If after stat equals null, after stat equals null, after end equals stat. Yeah, I think I don't understand it now.
Yeah, I go by memory. Remember, you wanted the list with numbers randomly distributed. I think that's what you got. The input was randomly distributed. You wanted to give the list and the number, and every node that was at the value lower than the number you wanted on the left of the number. So
Yeah.
you reordered it so that every node with a value less than a number was at the left of that node,
Yeah.
and
Yeah.
every is on the right. So what they did was navigate, go through the list, visit the list. Was there an additional condition? Because somehow you started with the node that you actually wanted. Maybe it's you start with the number you want in the middle.
Mm-hmm.
So I'm thinking I think there was another condition that I'm not remembering. Oh, it cannot. Oh, interesting. Well, yeah, you put. Yeah, no, this works. You put whatever is the first one as the center, so to speak.
Yeah. Yeah.
And then you just make sure, because if you do the comparison right. Yeah, but then how did you wait? Yeah, you're right. This is not. I don't remember it very well either. Let me check very quickly. Oh, but yeah, no, he actually created two lists.
Yeah, you see, I think this is the. I don't know why I don't get to understand recursive solutions faster. I think
This one is not recursive. This one is not
Oh,
recursive.
it's iteration, but it's.
Yeah, that's probably why we're expecting it to be recursive and it isn't.
Yeah.
It's strange because this code is actually pretty clear, even if it's camel case, which I have problems reading usually.
Mm-hmm.
Try reading the commands like they were sentences. It really helps. And that's why I am insisting in naming the things right so that they make sense when you read them. And he did a good job at that.
Yeah.
Sometimes he didn't, to be fair. But I mean, before start, after start, yes, I can understand what that is. But yeah. Can you see it now?
Yeah.
Okay. So can you look at my code? Your code that I just hijacked. Look at the last method. Tell me if it's not clearer now.
Add head.
Because that's what we're doing. This is going to be the new add. And it doesn't work if you don't want it to be the new add.
Yeah.
Well, technically, the possibility is you can actually save the head before then. I mean, you can make it work, but the point is if you call it just as it is, you need to know that it's going to return the new add. You need to be careful otherwise, I think.
But do we need to return this list? I think so.
Why did I do that? I'm just actually this is going to be a problem because it's a reserved word, right?
Yeah.
So this is not going to work. We are updating the list.
Yeah.
So we passed at the beginning. We pass L1 or L2. And these are the heads of our things. So it should be, this should be by reference, right? It's not a copy.
Yeah.
So we are just updating the pointer, and we don't need to return this unless you want to. If you see,
Okay.
we are not using the return, but yeah, you can always return if you want.
So at the end, the pointer will be, L will be pointing to the first 0.
Yeah, it should.
And there will be no point on.
Sorry, I lost you for a second.
Yeah, I'm saying in the end, L will be pointing at the first 0.
It should, yeah.
Yeah, and when we call our pad list, L1, which is L in this case, will be pointing to 0, just in case it was being padded.
Sorry?
So since we are just updating pointers, and here we are passing like L1 in this case.
Yes.
Say here we are passing L1 and here we are passing 1. And this iteration will run once, and then L will be made to point to node 0, which is this. So it will correctly point to this first 0, which will correctly point to the L1 that we passed here.
Yeah, I mean, L1 will be updated to point to the new first node. Yeah,
okay,
but that's what should be.
Yeah. That's what we expect. Only that we are waiting to test that. We are waiting to test that later.
Yeah, this time, just this time.
Yeah.
I don't expect this to work. Nothing I write without tests.
Yeah. So and then now, after we do the padding, I think we want to like. So we have the lists that we should be adding. So we need to like call the recursive function that does the addition.
Yes. And then return it. That's it, I think.
Yeah.
So, I might be looking at the solution, but you shouldn't.
Sum equals.
Oh, interesting.
I think I want to change this to add lists. Or maybe.
Yeah, maybe.
Yeah,
I might actually say keep it add and change the class into list utils because it makes more sense.
Okay.
What do you think?
Yeah. Good call, bro. So here we have sum equals self dot
oh, sorry. Just call it, you can call it. Sorry, you could call it unless you want to call it like add recursively or something like that.
Huh? Name, I know it's.
Well, at least call it some lists.
So in this case, we need to return yeah, in this case, what do we want to return? So if both are nil, if both are none, it means we have traversed to the end of the list, right? So we need to return this still here.
Hello.
Hello. Hey.
This is irritating.
The internet disappeared?
Yeah, I lost connection for a little bit. It's probably going to happen again. What did I lose?
Yeah, so in this line 20 to 21.
Yes.
So
Okay.
in my base case, I'm just thinking, okay, when list is none and L1 is none and L2 is none, we actually don't have a sum, right? And our carry is 0.
Yes.
So I'm just thinking, And then at this point now, so I think sum of lists should be equal to sum list, and then we call L1.next and L2 next. So that will keep iterating.
Can you? It's okay.
Like recursing. And then
Now we are in
this,
the return path, right?
yeah. So sum of lists should be
Well
equal
done.
to sum of lists, sum of nodes, I think.
The sum of last is more interesting than the sum of lists.
Last node? Sum of last node should be equal to.
Oh, no. Sorry, mine was a joke. I went away a second. Apologies. So it's fine. I would even call it sum, just sum, but.
Yeah, sum is also a keyword. So I can do this. I can do
Okay. Then feel free to change it as you want.
Yeah. So sum should be.
Is that acceptable in Python?
Yeah.
Okay.
L1 value. The file I mean. I think I need like a for my being. So sum carry I can do should be equal to div mod. That's a function, and should be I don't know what I'm doing, but
it's unclear.
it's not clear. So I want like to get like the. You see whatever we returned here.
You're preparing. What do we do when we're coming back?
We want to add the carry to the values.
Well, okay, it's okay.
I think I made it that file because
My internet seems to be stable, so I'm going to join again.
then sample carry equals divmod. And now we want to
Can I do it the other way around? How about this is what we're going to return, right? Why did the example called it sum, but that kind of sucks, doesn't it? Because this is not the sum. This is actually the result.
yeah.
Or I'm just trying. That should be like this.
So the new digit is what I have as sample.
Oh yeah, I was just sounding the names of variables in my head, so that might actually.
Yeah.
Because I would actually use result list. Or wait, this is a different thing though, isn't it? Because this one is something like this one. So sumval. So new digit would be. I'm doing it the other way around because so I know what I need, right?
Yeah.
Can you do it like this? No.
I think divmod already cares for that. So like if you do divmod, it gets the sum and it gets the carry.
Okay. What am I missing?
Yeah.
It should be correct, right?
I think so.
So we are missing some lists. Oh no, this is not. This is the same thing. The only thing I really don't like is this underscore here.
How will you put a better name? Partial result. That's what he said.
Why am I auto-completing? It's doing it wrong.
Yeah.
No, I want to. Yeah. Is this clearer?
Yes.
I mean, so this one, 2, and this is the dot, by the way. So we are missing one last thing. So I realized we are missing one step in add after you do the sum, and I'll give you an example. See if you can tell me why. Does this work? Yes.
Yeah. So in the last, if we have like an extra carry.
Yeah, exactly. Well done. But that's actually really easy, right? You just need to realize that that situation can happen. So you've already done all the job, because and this is not going to work, because did you say that sum is we cannot use sum?
Did I say that? Yeah, we can't use sum. I think we need an underscore. Result.
See, I don't.
Yeah.
Python is really a pain in the ass, though. You cannot use. Go ahead. Sorry.
Yeah, I was just scratching my head where I should add that function. Where should I add this, the result thing? Like the line 19 to 20, I was like, where should I add this fucking carry? I think you can just do return. Yeah.
Which means.
So you can do it on our onliner.
Oh. Yeah, but it's going to be very, very long. I don't like it.
Yeah, it's going to be very, very long. Yeah.
Okay, do you see? I like separating things. You notice that, right?
Yeah.
But yeah, this should be the idea, I think. Now, one thing you might want to do is, I mean, we can refactor this if we want to, but the whole point of the exercise is doing the exercise. So if you are quick enough, and you say that if the interviewer wants, you can refactor this, otherwise this is good. Well, now we test it, right? We run it and see what happens. But I wonder if in an interview where they ask you this, you should just say, I would refactor at this point, but this is fine for you, we could go to the next exercise, right?
Yeah. You want us to refactor? What do you want us to extract?
No. My fingers want to refactor.
Yeah, we can refactor. I can learn from that.
Yeah, but
you want to extract.
My head is telling me that this might be. We need to remember that you asked the interviewer, right? Because maybe for him it's more important to know that you are going to do another exercise, and maybe he wants you to do another exercise. So remember to ask for these kind of things. That's it.
What does your finger want to refactor?
Let's check if this works first.
Okay. So
I'll tell you a spoiler though. At some point, I thought we should put a comment here.
comment where?
No. This is the spoiler.
Okay.
That's why I want to refactor. One of the rules is if you see a comment, it means you probably need to rename some things, and you can remove the comment.
Yeah.
Node new, maybe. Yeah, right. I'm being using node new. Is that correct in Python?
Nope. Don't need to use it.
So you probably fixed it where I put it that then because I don't see it anymore.
Yep.
Okay. Well done.
Probably I did. I can't remember doing it though. So maybe this is L1.
Try adding like 9.
I can
just
okay.
yeah,
How should I do that?
I want to see if the padding works. Oh, 9 went away. Where did it go?
I did undo.
Oh, maybe it was made then.
What happens? Like if I yank?
Yes.
Then Control
Control E. Control. Can I say that again?
I did Control A, and then I want to do Control. How do I find the first number and add to it?
Oh, Control A.
Yeah. Now, yeah.
But on a line, you need to be on the line. Maybe you don't have it. So, oh, wait. Control A. Yes, Control A. Yeah, but. I mean, don't worry. This is good. How do you print?
Print with.
Well, how do we check? We just print it out and see how it goes, right?
Yeah, I think you want to create like the utils object first.
Oh, I thought it's not static, huh? All that self, having to write self everywhere was confusing me.
Yeah. So I think I think this will make your print cleaner. So print utils dot. Is it add? Yeah.
Yeah, L1, L2. Okay, is this going to work even if we don't have I mean, do we need a toString method? Maybe.
We can do here. Where do you want that?
What would you put it in the node or in the utils?
I don't know. What are we printing here? We are printing a node, right?
Yes.
So we need it in the node. So what we'll do is like for come on.
If you feel that it's behaving strangely, try pressing ESC a couple of times or check if your caps lock is on.
Yeah.
Otherwise, it's the extension that's not working. Oh, I see. I see.
What do you want to print?
Well, how about... Ooh, my fault. What did I just do?
You can undo.
If I undo, it's going to undo. Oh, it's not. Oh, it's not undoing your thing. It's undoing only mine. So it's putting me way back. So it's better if I don't. I wanted something like. How about? How do you like? Did you like this way of writing it?
Yeah.
Or maybe as an array?
So maybe you want to like have a while loop inside there, inside the string function.
Yeah, I think I'm going to cheat, if you don't mind. GG, come on, again. Oh, you know what? I think it's confused. It's doing, yeah, okay, it's a problem even for me, I think. But anyway. Well, we know we have a node. So one thing we could do is like result.
So you want to say while self? Or probably you want to iterate through result.
Should I do like string? No. How do I make, this is an integer, right? How do I make it a string?
That way.
Okay. Oh, right, I had an example here. How do I append strings plus?
You want to like?
I don't know if I like it. Okay. What if I build an array and then implode? Can I do that?
You want to print the array? Yeah, you can print this list.
Something like, oh yeah, but I want actually string to be sure. So how do I? Is it like Ruby?
Dot append.
It's like Java.
Java uses append?
No, not really, but uses a method. What's the method for doing the join? Join?
I think you want like, yeah.
Something like this?
Nope. Result.join. You just remove the result.
Okay, so I'll do it like this just because it's easier. Okay, cats. You're recording this, right?
Yeah.
luckily, I'm swearing in Italian. Okay, how about this? Does it sound competent?
Yeah. But why are you not iterating through? Why are you iterating through?
Because it's not competent, right?
Do you want to change the value of self, or do you want to assign this to a variable and then iterate through that variable?
You know what? You have this clear? I mean, you understand what I'm trying to do, right?
Yeah. Understand.
You are the Python man. Would you like to do it?
I'm just thinking on the linked list perspective. Like, I think the other time you told me that when you do .next, because I think here you'd want to like do.
Yeah, you're right. You are absolutely right. At some point, we need to create a node somewhere. Point to an, well, it could just
But-
be something like this, right? It could be node
But
self. Then you do node.
yeah,
And then you do node. Oh God. You do node.
yeah.
And
I
then
think
you do.
yes.
The only thing, okay, so if I do it like this, this should be here.
Yeah.
Maybe it's a bit better like this. Should work for one. Do we want to try it?
Yep. That's good. So terminal, where are you?
Do you see it if I put it out? No, each one needs to do it independently. Each one of us.
What was the name of the file? Yeah.
Okay.
So next node, missing one argument, next node. So
Oh, I'm following you. So this makes probably it's the reason why it's making so much. Does it tell you where? 59.
yep. So we need to like default it to none.
Oh, I see.
So
list util some lists is not defined.
That's line 35.
Is it because we didn't have a self?
Yep.
Oh, we missed one.
Next node.
Oh, that's because the padding is not working.
Did we need to return a value from the padding? You can print L here. Try this out. Well, node.next. Node attribute has no attribute next.
Oh, well, yeah. Agreed. Because in some languages, next is apparently a reserved word. Oh. Did I do this mistake somewhere else?
I don't know. Let's see. Because node attributes next sum.
Okay.
It should be next node, I think.
Yes, but I'm pretty sure. I mean, it's messing with me. Changed.
Okay. Object has no attribute join. Yeah, I think it should be this way.
But why list? Oh, really?
I think so. Let's try. Object has not boot next node. Non-time object has not boot next node.
Well, apparently we didn't go through the padding, or
Partial result. Do we need to return this and assign it to that value? I'm not sure if this.
but it's is it padding? Let's check that we are padding first. Try now, or could you give me
Control, yeah.
Yeah.
Why do I only have read only?
There are two. I see two. Okay, I think I can now. Thank you. Oh, so it is working.
Where did you
So
add here?
the question is, I just removed the print thing.
Okay.
The question then becomes, how is, so the shorter one is L2. So I would really like a print, oh, freaking hell. I would really like a print L2 here then. Aha.
9.
You might be right then. We need to. So does this mean that it's not passed by reference then? It's not updated, which means that you were right, we need to return.
Maybe, I don't know. We can try.
That sounds kind of wrong though.
Yeah, because it's a linked list, right?
Yeah. So maybe the problem is elsewhere. Oh, good. Actually, I'm actually happy that this is the problem.
Did you? Did it change? Did the? No, the error did not change.
You saw nothing. You saw nothing. That was a very big mistake. I actually assigned the wrong things.
Okay.
Oh yeah, so that's the problem. Wow. Result list is not defined. Really? Didn't I? I'm curious. 35 here. Is it not how it works?
Yeah, when we are at the end, we can't return a node.
No, I mean, apparently the way we wrote that object is not correct. Line 35. It's like we cannot use it as an index for some reason. Should that be a string?
No.
It says that this return list is not defined. Let me check how it works in Python.
Maybe you're right, I think.
Oh, I hope I'm not. This is really, really painful as a language otherwise.
Python hash, Python dictionary, not. Yeah, it should be a string. The fuck is going on?
Because they don't have
Atoms.
symbols.
Symbols, yeah.
Should be correct. So this means carry as well, right?
Yeah.
I missed one.
009
Wait, what?
is printing 009 here.
Oh, yeah, no, we were all, yeah, let me move it. We were all already over that one. The thing is, attribute error, dictionary object has no attribute carry.
Yeah, so you need to access it using square brackets and then.
How about class
but
Python? I hate you. How about class some results? Some partial result is actually a class with a what's it called? Result list. Why don't you like it? Oh yeah, Python. Okay. Do you like it now? Good boy. Yeah, I was going to do this later anyway, but I see a very good reason to do this. So, how did I call it?
Some partial result.
I'm not sure the name is very correct, but you know.
Yeah, will save us the problems. None.
0 is a default. Yeah, okay. I might actually, it's better if I don't. I want to be explicit. The only thing I don't like is that I'm not saying which fields these are.
Yeah, you can do that.
Yes? How?
Yeah. Just some like result equals none.
Oh, okay, this is good. It's like the thing in Ruby then. Okay. And now the rest should actually work with this one. Oh, this was actually a mistake. So this is some partial some result. Self add result list carry is carry. This is like this. And there was a third one, wasn't there? No.
No.
How many mistakes did I make? Okay.
Name val is not defined.
Oh, this is fine. I'm not flocking. I'm not testing. I know I'm going. Maybe this is wrong. Line 4. Yeah. Okay. I see, because it didn't change this one. I'm still letting the compiler guide me though. I mean, I did it again. Yeah, here it is. Doesn't work.
Result list is not defined.
Oh, sorry. Jivko sent a doodle request to have a
Okay.
catch up, discuss roadmap, architecture, and moving forward. Jivko, I want to see how Ethan responds to this, though. So let's go ahead. What does he want?
Line 40.
Well, he's not wrong, right?
This is partial sum, partial result.
This is new digit added to. I need to add a new node, new digit added to. That would be partial result dot result list. The names really need to be worked on.
Carry is not
Really?
defined.
Yeah, but why? Where? Here?
Line 32.
He might be actually right? Because this is result of carry, I think.
Mm-hmm.
Oh.
Yeah.
This is actually wrong, isn't it?
It's wrong.
This is,
It's
yeah.
It's 909.
This one should be should be you adding 910. Sorry, 110.
Yeah, 110.
Okay, we get. Okay, let's do this.
You want to do tests?
I want to do make this thing easier. So I can do something like. I want to just do 1 and 2 then. 1 and 1. Oh, wrong system.
20.
Why?
Let's see. So in this case, we are not doing the pad.
We shouldn't have the carry.
Yeah.
It's going to come back with 0, then it's going to do. Well, the div mod is probably working correctly, unless.
Yeah, maybe.
Okay, this is a little bit. Which one is the? Yeah, this one. So let's see. Partial sum is 0. Yes, it's the opposite.
Indentation. Line 44.
Where, sorry? 46?
Indentation on line 44. This.
44.
Okay, let me just let you do it. Yeah.
No, go. Huh? Why? Oh, I see it differently then. Wait. Where do you see it? Oh, you see it correctly. I see it actually 2 tabs right. So I lost synchronization. I'm going to go out. I'm going to leave it to you then. Does it look good? It looks better. Yeah, of course it's printing something very strange, but maybe.
Yeah, I don't know why it's not printing what we want it to print.
Remove the 2 prints now, and let's see what happens.
Yeah.
No, the 2 I just added carry and some result around 40 something, 44.
Or around line 44.
Yeah.
Okay.
D to D. Mm-hmm.
Then why is it not printing what you want it to?
I mean, this is not a mistake, right? Maybe a mistake I made with the test function. Oh, it's a sum partial object. There is an error in the return. Go to the first method. Now this one is correct. Def add. Towards the end. This sounds right. So maybe in some lists I am. No. I am actually wrong, I think. Go a little bit up. Yes, because I'm returning a result. I want to return. So this is going to be tricky because now 32 and 34 don't match. So please feel free to make it work. See what I mean? You still there? Yeah.
Yep. What do you want to return here?
Result list. But then 32 is not setting the result correctly. So I would like a return there at this point instead of result equal, right? Because that's a list.
It's not behaving correctly.
No, return. Sorry, direct return. I'll remove 1 space. I think there's 2 there. Try now.
Yeah.
Okay. Let's try to see if the last carry is carried over. So something like 1 and 9. Oh, I would have used the last one. But yeah, this is actually, no, this is better. Yeah, you can just do Shift D.
Shift D?
Yeah, this is how I do it. Shift D, Shift A, or A, simply A.
Okay.
It's easier than going to look for the dollar. This should be 1-0. Let's see if this works.
Yeah, that works.
Okay. You know, now that I think about it, one last thing, because these are numbers. Why am I putting arrows in there? I'm still thinking about lists, right? But if I want to print it, might as well print it as a number.
Yeah.
So just join. Can you do nothing? Empty string? Ooh, wait. Can you undo what you just did? Let me show you a couple of tricks. Oh, it does the same thing for you as well. Anyway, right side. Okay, one thing you can do is there is a movement that is everything inside a certain symbol, and that's I and then the symbol. So you can do, for example, did you just do the I quote?
Yeah. The first time I did change inside then escape, but I can just do the
Yeah, it's the same. It's the same thing. Often I do it. I'm so used to doing change that for example, another thing you can do if it's a word, you can just use IW as in inside the word, which means wherever you are in a word, whichever character you are, it's going to operate on the whole word, which means it's going to delete it or change it. And I use CIW a lot, especially because it works for a list of spaces or tabs. So for example, if you go to line 22 at the beginning, 0, press 0, and you do CIW. Whoa, that's too much. It should have just deleted everything, including the return, it should just, for me, it would just remove the spaces.
Oh, but that is like DW does that.
Yeah, but you need to do it. Oh, right, because it's still a word. Right. But the thing is, DW is going to move either W in general is in E. They are going to move either right or left. So if you are in the middle of the word, it's going to work only on half of the word. If you want it to work on the whole word, wherever you are, you do IW. I don't know if this was clear.
Yeah.
And this is extensible actually. You can do you use I as inside, and then you can say inside a symbol like a quote, inside double quote, inside I don't know, underscore. But you can also say inside the paragraph, which I think is P. Or you can do inside the tag, if tag is defined, which will delete the text inside an HTML tag or XML tag. You can try, let's just say you can try with something that makes sense and see if it works, because often works.
Yeah.
Yeah, okay, so this is the exercise. I hope I was not too much. Yeah, that's too much better. I hope I didn't hijack the thing too much.
What, the session?
Yes.
No, actually, it was an interesting one. Yeah.
Now let me give you a couple of ideas, because I've been studying about smells, right?
Yeah.
And one of the things I did is, can I share my screen?
Okay. Oh
Because
shit.
this thing is actually really, really useful. So these one are the smells. These are the solutions. Sometimes just studying the solution is not bad. Which one was? Let me see. Could smells. This could be long parameter list, for example. Treatment for a long parameter list is introduce parameter object. This is not the case. What did I do? What I did in the code was, this is actually preserve all object, I think. No, I'm gonna get one. Crap, what was the name?
I can stop the broadcast now because it's being too long.
Yeah, also I'm